Hello everybody, and so like I mentioned, I'm going to start will be just me here on the screen, and then we'll transition to have you and everything, okay? And we'll flip here for a second. Hello everybody, and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano da Silva, and I'm your host. And today we are ready here for another great presentation on our worldwide tour as we engage with different presenters from around the world that bring us great knowledge and an opportunity to engage and learn on different technologies. So before we get started, I would like to just remind you to please take a minute to subscribe, click on the bell so you can be informed when new videos are added to the YouTube channel, and drop a comment and like the videos. And second note here, just to remind you that we are engaging here for the upcoming fourth quarter of the year. We will be bringing you our next event on October 7th. We are going to be talking about cognitive services, so extending and still related to what we are talking today, as well as what the group's all about: machine learning, artificial intelligence, and data platforms. So let's transition here and take a look at our guest. We have Kevin Feasel. Thank you very much, Kevin, for making the time to present and join us on the user group. And today, sorry, I didn't hear you, please.
I was just saying, I'm glad to be here.
All right, and welcome. And today we will be talking about developing solutions with SQL Server machine learning services. And we're going to engage some Python as well as R programming. Can you tell us a little bit about it?
Yes. That's the best answer to that question is yes. I can tell you quite a bit about it, and we will cover it in great detail. But it is all about integrating SQL Server with Python, with R, and even with Java. Although we're not going to do that tonight.
All right. Yes, I did see about the new, I believe, is language extensions is the proper nomenclature for machine learning, machine learning, SQL Server machine learning services for that came out with SQL Server 2019 with the extension as you mentioned about Java.
Mm-hmm.
Great thing, and we also appreciate your contributions to the community here as great also hosting your group. Want to tell us a bit about your user group?
Absolutely. So I am the president and not so benevolent dictator of the Triangle Area SQL Server Users Group. We're out of the Raleigh-Durham, Chapel Hill area in North Carolina. We meet usually about up to 3 times a month for regular sessions. And also once a week, we have a 1-hour get-together with several members of our board, which we call Shop Talk, where it's just Q&A with the audience, having fun talking about topics. You can find our group at meetup.com/tripass, TRIPASS, and we broadcast all of our streams on Twitch.
All right, and folks, we'll also get that link from Kevin and add to the description, to the comments below. And we'll also share via email whether you sign up via Meetup and or Eventbrite, so everybody can follow up and engage in another great resource here for you to learn more about technologies. All right. So let's take a look now, folks, on the presentation. Anything else there you want to add, Kevin?
Nope.
All right, so let's transition here to the presentation.
Sounds great. I'm going to start sharing my screen. And as long as I share the correct screen, there we go.
All right, yes, we can see it here.
Fantastic. And if there are any questions throughout this, there will be several natural stopping points. Drop your questions in chat. I might be able to see them and recognize them. Adriano could also absolutely please jump in with any questions that come up. But we are going to talk about developing a solution using SQL Server Machine Learning Services. As mentioned, my name is Kevin Feasel. I'm a manager of a predictive analytics team here in Durham, North Carolina. I'm also a Microsoft Data Platform VP, and I run a blog called Curated SQL. The idea of Curated SQL is I like to try to find and link to 5 to 10 interesting posts per day on topics like database development or administration, R, Python, Hadoop, Scala, Spark, Power BI, reporting services, security, or anything else in that broad data platform space. So that's at curatedsql.com. So let's start off with an easy question. What is machine learning services? By the way, I'm going to look this way a lot tonight. It's not because I don't love you, dear viewers. It's just that my screen is over here. So I'm going to have to live with it. SQL Server Machine Learning Services was initially released in SQL Server 2016 as SQL Server R Services. It was an integration of R with the SQL Server database engine. With is the right preposition here. It's not into the engine. R is still separate from SQL Server. It's just that there is a nice interface from SQL Server into R. In 2017, Microsoft added Python and renamed the product to SQL Server Machine Learning Services. In 2019, there's been some additional changes to the product. There's the addition of Java support and this language extension framework that can potentially support other languages as well. That's a little bit outside of where I want to be tonight. Tonight, I want to focus mostly on the R and Python side of things. So what I'd like to do in this talk is introduce you to machine learning services. My assumption is either you've not used it before or you've only used it a small amount. So let's cover a scenario where machine learning services might be a fit, but also cases where it's really not a good choice. We'll very briefly cover installation and configuration and focus mostly on external script execution, building out a project, deploying our own code. So here's the agenda. Anytime you see one of these agenda slides, this is where I'm going to stop, take a break, ask for questions, or at least I'm going to try to remember to. So if you have questions, this is the best time to ask when you see one of these slides, or really probably half a minute before you see one of the slides, just because there's a little bit of delay from when I say the words and when they show up over there, just for broadcasting. So get your questions in. We'll answer them whenever you see one of these slides. Okay, how does this thing work? As I mentioned, it's not built into the database engine. R is a separate process. So in this image, which comes from Microsoft, they describe it as a SQL Server process, SQL Server.exe, which then calls out to a launchpad. So this concept of the launchpad is, well, I have a reference to an external product, r.exe, or R command, R term, and I'd like to run some code over in R. So we've got a DLL that understands how to translate what I send it from SQL Server, get it over into R. We spin up a process within the R terminal, which runs R. It does all of its work, and eventually we're going to get some results back through the SQL satellite service. This is definitely not intended to be an internals talk on the major in-depth discussion of how this product works internally. I just wanted to give you some, say, baseline of the fact that this is still a separate product. You are still reaching out to a service. In 2017, we bring in Python, and it looks, well, pretty much exactly the same, except that instead of blue, we have yellow. The Launchpad service is still the same. Python executable now instead of our term, but conceptually, at that architectural level, it's the same. And that's good for us. There's a very minute difference between calling R code and calling Python code, as we'll see. There's a very minute difference in managing R versus Python code. So, if you are a DBA, it's pretty easy to pick up on one versus the other. One of the most interesting features within machine learning services is this notion of native scoring. SQL Server has a few models where they've pre-developed DLLs in C++, native implementations for certain algorithms. And these algorithms are the ones on the screen. Now, they are the very specific forms on the screen. So this is in RevoScale R, which is a library for R, or RevoScale Pi, which is a package for Python. The RxLinMod is Microsoft's linear regression. RxLinMod and RevoScale Pi, same thing. Where this is critical is that in R, there is also a built-in linear regression, LM. Running LM doesn't give you native scoring. Running RxLinMod can give you native scoring. Native scoring allows for use of a predict function and is enormously faster than pretty much any other method available. So the upshot of all of this, by the way, we'll talk more about native scoring in demos, so don't feel like that's, hopefully I'm not rushing too much on this. I'm excited about native scoring. I want to show you just how it works. But for now, that's enough. Machine learning services will bring you, essentially bring your code to the data, reduces data movement. When you think about having a large amount of data, moving that over the network takes time, takes resources. Moving code to where the data lives, well, your code is going to be typically a lot smaller than the data that you're working with. And as your data sets get larger and larger for training machine learning models, it can make sense to say, well, why don't I just run my R code or my Python code against this server? Where it might not make sense is, well, if this is an active production server that's being heavily utilized, yeah, R and Python are very resource intensive. They will spike your CPU, especially if you don't have GPUs attached to your SQL servers, which most of us don't. So to that end, if you do want to use machine learning services, you can use Resource Governor to limit CPU and memory utilization. This talk will not get into that because this is mostly on the development side, but I have an entire talk on machine learning services in production that covers Resource Governor as one of the topics. So if you're interested in that, go check out that talk. There are some scenarios that work really well with machine learning services. One of the key points is your input data really has to be in SQL Server. If your data is not in SQL Server already, then machine learning services is not necessarily a great choice for you. You can work around it by bringing the data into SQL Server, but this is really meant for data that's already there. You also should have longer running batch processing, batch training, batch scoring, because there is a cost for that launchpad. There is a cost for spin up. My experience is that it's anywhere from about 2 to 6 seconds, depending on how grouchy the server is at that point in time. So you'll have that overhead, meaning if you need this prediction immediately, you need a real-time prediction, well, you're not going to get it. It's going to be several seconds from now. Unless you use the predict operator, native scoring. That predict operator, because the algorithms have already been implemented as DLLs, written in C++, essentially you can call that predict operator and it will come back nearly instantaneously. You can feed a lot of information through predict, get results back extremely fast. This is where you can get real-time scoring if you're able to use one of those few models that allow it. If you want to interact with .NET code using R, there is a library, r.net. I'm not a big fan of it. I don't think it works very well. And it could just be my failings, but we actually found that r.net wasn't a good fit for our company. We ended up using machine learning services as our gateway between .NET code and R code. Now, on the other side, there are plenty of scenarios where machine learning services is not a good choice. If you need that singleton near real-time lookup and you cannot use native scoring, machine learning services is not a good choice for you. If none of your core data is in SQL Server, you have to bring it all in every time. Machine learning services just doesn't make much sense. You're basically paying a lot of money for SQL Server, but not really using SQL Server. You could just stand up an R or Python server standalone for a lot cheaper if that's your idea. Like if all your data lives outside of SQL Server and you're only using it to call R or Python, there are better choices. If your SQL Server instance is near capacity or at capacity, especially CPU, ML services can knock you over. It can push you over the edge. I've had cases where I've had CPU spike to 100% for hours or days at a time because we were training a large number of neural networks. They were individually small neural networks, but we were training a lot of them. So that can just kill your server. In our case, it was okay because that was the only thing it was doing. But if you're also trying to run a transactional system, that's not acceptable. I want to leave a quick note on Azure SQL Edge. If you were an attendee of Ignite today, they talked about Azure SQL Edge, how it's now generally available. One of the interesting things about this product is that it includes support for ONNX, which is the Open Neural Network Exchange. The idea of this is you can generate a model in, say, TensorFlow or PyTorch or Caffe and save it in an ONNX format, which is an open standard for neural networks. If you bring that model into Azure SQL Edge, you can then run the predict function and perform native scoring on that neural network. I would love to see this on the on-premises SQL Server product. I hope it will show up there in the next edition. I would absolutely love to see that, but it's not there today. If you want to do ONNX native scoring, it's only available on Azure SQL Edge, which has its own licensing. It has its own scenarios. So I did want to point that out, that predict hopefully in the future will be a bit more helpful for us. And if it can support neural networks, that opens a lot of doors. So at this point, we have reached one of our agenda spots. So far, no questions, but if you have questions, feel free to drop them into chat. I know that this early on, it's basically, I'm trying to set the table and give you an idea of where we're going with it. So you do have questions, happy to hear them. In the meantime, I'm going to talk about installing machine learning services. So installation starts pretty easily. You open up SQL Server Installation Center. You say, I want a new standalone or adding features to an existing instance. There are two choices. Realistically, you are almost always going to want the items selected in that box. So in database, R and Python. Now, as I mentioned, it's not truly in the database, but this includes the Launchpad service, which is in the database. So, or at least very close to the database. By contrast, down in shared features, there's this standalone machine learning server. Standalone machine learning server is really for instances where you don't want SQL Server You just want to use Microsoft's machine learning server. This is where you may have an R or Python server, but no SQL Server instance. You still have to license it for machine learning server. Have to talk to somebody who knows more about licensing than I do to know the exact details on how much all of that costs. But unless you are talking about that scenario, pretty much never want to check those boxes. Only check the in-database options. After installation, next, setup, do all of your setup, do all of your configuration for that server. We'll go to SQL Server Management Studio or Azure Data Studio and execute spconfigure external scripts enabled. So this will allow you to run R, Python, Java code from SQL Server. Have to reconfigure after that. And then after you've done this, there is a service that's called the Launchpad service. So it's installed when you select the in-database product, and make sure that you restart that service. You may also want to restart the database engine as well. Technically, you don't have to. I remember early on in 2016, we did run into some problems that seemed like they were fixed when we restarted the database engine the first time. So just general advice is restart the database engine too, just in case. So we've hit the next point where we are going to install some packages. So right now, where we're at is we have machine learning services. We have R and or Python installed on our server that runs SQL Server. So when you check that box for R, it actually installs a version of R that Microsoft handles. If you check the Python box, it installs a version of Anaconda. So we've got that. We now would like to install some packages for it, because that's a big part of the value of R and Python is that extremely strong third-party library scene. But we've got several techniques for installing packages, either in R or Python. I'm going to give you 3 options that I consider the best options. Now, specifically, these are typically the best options for 2019, maybe 2017, maybe 2016. So I'm focusing on 2019, but I will tell you about how it differs between versions. First, the best option is SQL MLUtils. This is the best way to install anything on SQL Server 2019, R or Python, or R on SQL Server 2017. It does not support Python on 2017. It does not support R on 2016. So you'll have to use a different mechanism to install than SQL MLUtils. So this is a package that is installed for R or for Python. Next, supposing SQL MLUtils doesn't work for us. You can use a console. If you have administrative access to that machine running SQL Server, you can pop open the Anaconda command prompt. You could pop open an R terminal and run installation. So for R, I can open up rterm and run install.packages in the console. Or if I am over running the Anaconda command prompt, I can run pip install to install packages locally. The R console is generally installed in this location that I give you. Basically, wherever your SQL Server installation is, usually in program files, R services bin, there is an rterm.exe, there's an rcommand.exe. Actually, I think it's r.exe and rcommand.exe. So rcommand is the one that you would open up, and you could run install.packages. You could do whatever you need to. pip.exe is installed in SQL Server Python services scripts. So you'd hop over into there and run pip install Werkzeug or pip install Bokeh or whatever package you want to install in Python. The third option I'm going to talk to you about is create external library. Now, this is mostly for 2017 and 2019. This does require certain rights. grant alter any external library and will allow you to install a package from a zip file. So if I have a package that I've already downloaded, perhaps it's not installed, it's not part of CRAN, it's something that I've custom built, then I can create external library, point it to a zip file, and say, here's my language. It's in R or it's in Python. In this case, I tried running it and I did not have that grant alter any external library permission. So it returned an error message and said, nope, you need to have permissions. Those are the three best methods in my thought. SQL MLUtils, first one you want to try. Use this for 2019 for a starting point, or if you're using R in 2017. Fall back to the console for fairly complex packages. For example, I tried to install Keras in R, and SQL MLUtils did not work. The only way that I could get it to work was to run Anaconda prompt and install TensorFlow and Keras in Python, and then install the libraries in R that allow me to communicate across to Keras over in Python, and do all that configuration on the server itself. So when shelled into the server, as opposed to using SQL MLUtils. I've also had some very large packages that do not install appropriately with SQL MLUtils. I have actually have an issue out with the product where we have a library that gets built. It's got a large neural network as a resource inside of the package. Easiest way for us to deploy it out. And SQL MLUtils chokes on it. So in order to install this library, I have to move it over to the server itself and then create external library from there. So create external library when SQL MLUtils fails. Let's look at a couple of examples of how these things work. I've given you the overview of here's when to use what when. So let's see them in action. So here I have a SQL Server instance. Figure out where my mouse is and move it over here. So I've got my SQL Server instance. I have a database called expense reports. Inside this database, I've got a few tables, and I'm going to tell you that I already have some stuff installed. So sys.external_libraries gives you an idea of the packages that are installed in R or in Python. Now, suppose I want to install something new. Well, I need to use SQL MLUtils, and you can download it from this link. So I've got a link to Microsoft's GitHub repo for SQL MLUtils, and it does require RODBC ext, though that is deprecated. At least last time I checked, this required RODBC ext. But that project's been deprecated, so I have to install it from a historical repo from back when it still existed. So I can run this, and it gives me a warning message because it was built in a different version of R than what I'm using, but I can ignore that because I've already tested that it works for my version of R. So if I don't have SQL MLUtils, go install it from GitHub, and I'm using version 0.7.1 in this demo, and call library SQL MLUtils. I've already got it installed, so it's loaded the library. Next, I want to connect to a database. In R, with SQL MLUtils, I have this connection info thing, this connection info function, and I give it driver details. So you're going to connect to SQL Server via the ODBC driver. I'm going to connect to localhost and the expense reports database. Now, if you need to connect using a user ID and password, here's an example of how you would connect to it. If you need to connect on a non-standard port, something other than 1433, here's an example. You would use comma port instead of colon port. So let's create our database connection. And if I drag this over just a little bit, if I go to environment, we've got database connection right over here. So it created successfully. I'd like to install a package. So I'm going to install the data table package. Great package. Like it a lot. And I'll use a command, SQL_install.packages. If you're familiar with R, you're going to be familiar with the install.packages command. This is how we install a package from CRAN or from a local installation in R. So to install this on a SQL Server instance with SQL MLUtils, we add SQL_ to it. I connect to my database. I tell it what packages I want to install, and I give it a scope. There are a couple of scopes, public and private. Public means any user is allowed to use this package. There will be one package for all users. Private means install it essentially in my namespace. So my account can see it, but nobody else can see it. This is where you may have a team of data scientists. They want to use different versions of packages, and so they install their own versions. And I can point to a repo where the stuff lives. Looks like right now it is currently working on trying to install. So while it's doing that, let's pop back over to SYS External Libraries, and I can see principal ID. Principal ID here, 1 is going to be DBO. And the scope for DBO is public. So in order to make this available to everybody, I actually have to be DBO. I have to be a sysadmin, a database owner, or control on the database. I believe those are the 3 options that I can have for installing for the public. Otherwise, I have to install privately for my own account. Okay, package is already installed, but the version is older than what's available in the repo. So basically it's saying, hey, you've already installed data.table before, but there's a newer version available. But it's not going to automatically update for you. So you can remove that package and then install that package, and that's how you'll update it in R. We can install multiple packages by sending in a list. So here I have Magrider, Stringy, and XGBoost. And I can install all of those packages all at once. And this is rerunnable, so I can rerun package installation, and essentially all it'll say is, oh, this is already installed. We don't have to do any more work. So it's a safe run. If I want to remove a package, but something else depends on that package, then I'll get an error when trying to remove. So I can remove a package with SQL_remove.packages. But if Stringy, for example, or String I, if that's how you want to pronounce it, if that's used by something else, then this isn't going to work. It's going to give me an error message back and say, oh, this is dependent on, or some other package is dependent on this. So therefore, no dice. Howdy, Ryan. Good to see you in chat. Did not know that SQL command, get a list of packages. Yeah, so there is an R process. You can use the stored procedure. You can also use in SQL MLUtils SQL_installed.packages. And this takes a minute. So the DMV that I showed you, sys.external libraries, pretty fast. There's also an external libraries installed, which gives you some information on a little bit of information on like how it's set up, what its ID is, and the language R versus Python. So you'll notice these come back really fast. This takes a little bit longer, but it gives me some pretty good information and focuses down specifically on R packages. So if I call SQL installed packages in R, it's automatically going to include only the R packages. If I call it the Python equivalent, it'll give me back just the Python packages. Now, of course, I can filter out like this. So I have no Python packages right now, but I have plenty of R packages. So we can see it just finished. So I can call view to load up a grid with all of the different versions. But what's nice about this view is it shows me the library path. So what is important about this library path is that I can see, is this a thing that is essentially installed with machine learning services because it's in external libraries? Is it a thing which is installed elsewhere? So here, this came with ML services. So it is in program data, MS SQL Server /r/library. SQL Server installed these when I checked the box. So you can see some of the things that it installed for us. But as I scroll up a bit, I get to the things that I personally installed. And you'll see them in an external libraries folder with some subdirectories. The subdirectories depend on the language, the user account, and there are, I'm sure, a couple of other factors that I'm not too aware of. But basically, I can see, okay, well, tidyr didn't come with ML services. Somebody installed it right here and made it available to everybody. I'm going to hold off on this step for a little bit and instead hop over to a command prompt where we're going to check it out in Python. So I already showed you I have no Python packages currently installed. So what I want to do is import SQL MLUtils, which then needs a scope. So SQL MLUtils package management.scope has a scope object, which we'll see in just a moment. I'm going to create a connection. That connection, SQL MLUtils.connection info and servers localhost database expense reports. Now, so far, this is looking very much like the R package. Where it gets a little bit different is right here. So SQL Python executor with a connection string, and then SQL package manager with a connection string. I can then say package manager.install. And so here's how I can get Werkzeug. I can upgrade if I don't have, or if I do have it already, but an older version. And my scope is scope.public. So I can set it to scope.public scope or private scope. Those are my two options here. So I'll run this and it'll take a moment. Once it's done installing, then we'll go and check the dynamic management view. We'll make sure that we have a Python package, which I suppose I can even do right now. We're Python. Check this out. It took a moment. I guess I was going to try to run who is active while it was being blocked, but while we're installing that package, calls to this DMV will block, or will be blocked, I should say. So it installed Werkzeug version 101. So if I'm running term color, let's see if I can sneak in here. Good so far. Who is active is running a query on session 103, and the wait stat is satellite service setup. Satellite service setup is one of the wait types for machine learning services. Basically, this is saying I'm waiting for that launchpad to finish connecting to Python and do its thing. This is a fairly benign wait stat. I wouldn't worry too much about it, but it is going to give you an idea of how much time you spend waiting just for that launchpad to start. So is this built on Conda, pip, or neither? So it is built on pip, as I recall. You definitely use pip to install SQL MLUtils, and I think behind the scenes, essentially it is using pip versus conda. So we've installed the term color package as well. Come back and run this, and now we see term colors in here as well. So this is one of our techniques for installing packages. Like I said, this is probably the best technique if you're using SQL Server 2019. If you're not using 2019, then you're going to be a little bit more limited in what you can do. In 2017 with Python, actually what my team ended up doing was we would essentially take the deployment folder for Python packages and copy and paste them over into the server. It's very hokey. Sometimes we would run pip install directly against the server. That's also something that you can do. You have other choices, but basically prior to 2019, that experience was not great in a real production environment, not great in an environment where you have regulatory controls. All right, let's talk about external script execution. Before that, I'll take this moment for a dramatic pause and a drink of water. If you have questions, here's a perfect time for them. Yeah. Thank you for that. I saw Ryan's comments and did respond to his comment as well as his question. And I'm glad to see Ryan in chat. Good seeing you again. It's been too long. External script execution. SQL Server has a procedure that is built in called SP execute external script. It allows you to run that R code, that Python code, even the Java code that I'm going to pretend doesn't exist. It functions a lot like SP execute SQL. So it's a lot like building dynamic SQL, along with some of the pluses and minuses of that experience. At its simplest, this is what we need to do. SP execute external script, language equals R, script equals print hello world. So we choose a language. It's just a string. So I can put in R, I can put in Python, I can put in Java. Conceptually, I could put in something else. Maybe in the future, we'll see something else there. Script is a script in that language. So it is just a string in varchar, as you'll notice, that is, in this case, R code. Our R code is printing hello world to the console. Now, if we want to do this in Python, the code is totally different. So unlike this, the call is like this. You see, we have SP execute external script, language equals Python, and the script says print hello world. Completely different. Here's another example, a little bit more realistic example, just a little bit more. I'm going to run some R code, and I'm going to pass in a script that I've already built. So perhaps I've built up the command within my stored procedure. I can build that up as SQL, as a string. I could build it with SQL statements. I could just build it as a string itself, but I like to take the script out of the call and replace it with some variable. Makes reading this a lot easier. Next, we can assume that this script does something with data, and I'm going to send in an input data set. That input data set will be named training data. So how do we get this input data set? Well, that's where the input data 1 parameter comes in, and that is select some columns from some table. I can send that in. What happens is the database engine runs that query, gets those results, packages it up, makes it into a data frame in R called training data. I can also send in parameters that will be passed into R as variables. So they become variables in R. I can get output parameters. So I can bring something back from R as a variable. So in this case, trained model will be a var binary max variable that I'm expecting to get back from this. So presumably this command, given the data in this table, will train a model, give us back the trained model, and that trained model will be this variable right here. So this is what I declare in my stored procedure. And the rest of it is my SP execute external script call. Again, this looks a lot like executing SP underscore execute SQL. So I've got a little text commentary that basically talks through what I already discussed. And that's executing a script. It's actually really easy. We're going to see several examples of executing a script. So I wanted to give you the code walkthrough before we get to the demo, just to prime you for it, give you some ideas of what they were thinking, how they were developing this. We're going to build a project. Here's the idea. This is our scenario we're going to cover tonight. Our organization figured out that there were some employees who were doing some shady stuff. There was some expense reporting fraud among several employees. Employees were allowed to submit expense reports up to $40 without having to give a receipt, but they did need to include a receipt for anything above $40. So it seems like there were several employees who began submitting fraudulent claims. All of those claims were under $40. And what I mean by that is maybe they'd go out to a place, have lunch, spend $8 on lunch, and then say that it was $40, and then they would pocket the remaining $32. So management wants to figure out how much we think the employees took above and beyond expectations. So let's talk about how we're going to do this. I've got an R package. I've got a project in R, and I'm going to basically walk you through the process. We have some model training, we have some predictions, and before I get to this code, I'm actually just kind of teasing you here because I don't want to show you the code just yet. Instead, what I want to do is show you some data. So keep that in mind. We're going to build a model. We're going to get to this point. But before we can get to this point, EBO.employee. We've got people. Now, we know who the fraudsters were. We know the people who were committing this fraud. We shook them down, got them to admit it. What we don't know is how much they actually defrauded us, because they did go out to lunch for those days, but they overcharged. They got extra, they got more than what they actually paid. So what we want to do is try to estimate what that amount was. And we've got this expense category table. We have this expense report table. Look at expense categories. We send all of these salespeople out to different cities. And just for simplicity's sake, I marked them as inexpensive, moderately expensive, and expensive cities. Because, for example, you go buy lunch in Manhattan, New York, you're going to pay a pretty good amount of money. Unless you get the $1 pizza that's actually pretty good. You could do that. You can get that for $5 and have dinner there. But as soon as you step foot in a restaurant, those prices go up way, way higher. Then you go to Manhattan, Kansas. It's a lot less expensive. So where you are obviously matters a lot in how much you're going to pay for meals. Kind of broke this out into 3 high-level categories so that we didn't have to look into a huge amount of detail on individual cities and what the costs of meals are. That'd be a little bit overkill for what we're talking about tonight. Expense report tells us about employees who went to certain cities on certain dates, and this is how much money they said they spent. So these fraudsters were kind of tricky in that they often didn't necessarily go up to the $40. Oftentimes they might have been at $39.12 or $38.55. That way it looks realistic. Maybe this was with tax without tip. Perhaps our company says we don't pay for tips. You do that separately or whatever. However it gets you to this number. So they didn't always go up to the very top level that they could have gone to because they didn't want to get caught. So we can visualize this. So make sure that I have Sanddance and the visualization installed on this particular instance. As I recall, Sanddance, oh, it is installed. All right, cool. So what that means is that I can run a query on expense report and I can visualize it over here with the visualizer. So let me see if I have that query right off the top of my head. And let's do this one. What I've got here is expense reports joined to a calendar table so that I can group it by year. And we have calendar year, number of expenses, total, and mean expense. So what we see is that our expenses in 2011, for example, we had $44,000. The average was $49.94 or 95 cents. We go up here, it's $49, $50, $50. Down near the end, it's $53.54. It's a little bit higher, but it's, like I mentioned, it's not like an enormous amount. They're not suddenly submitting $500 lunches because anything over 40, you need a receipt. But we can see that there is an increase. Where I think we're going to see a better view of the problem is with this query. We have expense reports and expense categories. And what I'm looking at is the year, the expense category, and then count, total, and mean. We run this, and I give you numbers. And we could look at the numbers, but let's visualize this instead. Now I probably have to bump this down a little bit so that Sanddance doesn't get all angry with me. And let's see, I could do this in a couple of different ways. I want to color by expense category for sure. So let's maybe do a scatter plot. The x-axis is year, the y-axis is mean, and color by expense category. And what we see is the blue at the top, it just bounces around a little bit, but it's essentially a straight line. The green in the middle, it kind of bounces around a little bit, but it's still kind of a straight line. The yellow, you can see two separate lines. So right here, 2017, we can see that there was a shift. We went from a mean of about $23.93 to a mean of $30. And it stayed at about $30 versus before when we were at the $23.24 range. So there's definitely a visual difference that we can discern. But that's not enough. That's, say, some high-level evidence that there was an issue. It may have helped our team figure out that, yeah, there's a problem and try to unravel the problem. But it won't answer our fundamental question of how much money did the company lose as a result of this? So that research done, here's another view. Kind of seeing the same thing, just with a different level of granularity. So let's build a machine learning model. Let's try to understand what the differences were in the pre-2017 model versus a post-2017 data set. We're going to write some code, build some models that'll help us generate expected amounts. We're going to do this in both R and Python today. To build an R project, this is where I was teasing you a little bit earlier. In RStudio, if you have the R tools project installed, you can say File, New Project, and then set a directory and build an R package in there. So I've already done this, and easiest way to see this is probably going to be to go up to this level. So in developing machine learning services, the GitHub repo, you'll have access to that. You can go into packages, and inside there we'll have expense reports R. And this is where I have my R project. Inside here, I've got some files that are necessary for RStudio. I've got this R folder. Inside there, I have my code. So you create the package, or excuse me, you create the project, you fill out your code, and then we'll build it. So here's me creating a package. I add the code in, and then in build, there's build binary package. If I come back here, I'm gonna drag this over a little bit again, build or build binary package. This will give me a zip file. I can build a source package, which is a tar gzip. If I build the source package, this will only work on Windows because I'm running on Windows. If I do this in RStudio on Linux, it'll only run on, if I do it on the binary, it'll only run on that OS. If I build the source package, it can build on other operating systems. So we've built the package out. So I want to build a Python package. So it's kind of similar. This is an example using PyCharm. So we give our location, define the virtual environment, say where we want the project. We can add the files, add new Python package, add files, modify code, build that thing, and deploy it. For today's demo, I'm actually going to give you R in a package and then Python outside of a package, just to give you both sides of the story, because you don't necessarily have to build packages, but I want to show you why you should. So let's go back to RStudio, stop with the teasing, and just show you how to train a model already. So here we are, trainmodels.r. Now, understanding this code is going to take a little bit because basically working with machine learning services is the combination of R/Python and SQL Server. So when I have my function train model, we take in this input data set and this model type. I'm going to get input data set from SQL Server. I'm going to get model type from SQL Server. It's going to call the train model function. Model type, by the way, is going to be a string that will represent either I want a linear regression model or I'd like to use XGBoost. So actually that reminds me, I'd better make sure that I have all of my packages installed. So let's run that right now. While that's running, I can keep talking about this. We're going to load RevoScaleR, which is Microsoft's library for machine learning in R. It's one of Microsoft's libraries for machine learning in R. And our model type, just in case you type in capital X or all caps or whatever, let's make it lowercase because string equivalency in R is case sensitive. So let's avoid string sensitivity issues. If model type is linear, we're going to call this function. If it's XGBoost, we're going to call this function. If it's neither, I'm going to give you back a message and stop. I'm going to say, nope, you have to give me either linear or XGBoost. So let's say you pass in linear. So we're going to call train linear model. That's up here. Given an input data set, we will call rxlinmod out of RevoScalar. And basically, we're going to build a linear regression, assuming that the expense year and expense category define what the amount should look like. So my thing that I want to predict is amount, or the thing I want to explain is amount. The things I have that I can explain it with are the year and expense category. And I'll send in my input data set. Now let's say instead that I called train XGBoost model. Well, I still have the same input data set. We're going to load XGBoost and the data table libraries. We're going to set our label. Our label will be the amount. Our data will be taking expense year and expense category ID, turning them into a matrix. XGBoost requires that I send in a matrix. I have a label and I have a matrix of inputs. So I call the XGBoost function. I send in the matrix. I send in the label, the thing I want to explain. I tell it you're allowed to go 4 levels deep. Essentially, XGBoost is gradient boosted decision trees. So without getting too deep into this, this is a decision tree model. Basically, a bunch of if-else statements. And I'm saying you can go up to 4 levels of if-else deep. You can go up to 6 rounds of training. So I'm not going to let the thing run all day. And I'm not going to let it overfit to the individual data points and give me an unstable model. So I've got that. I'm going to get back a result. That result will be called model. This will be the actual model that we trained. And what we're going to do is serialize that model as binary and return it to SQL Server. So let's look at the SQL Server code, the T-SQL code that will support this operation. Come up here and say, do we have a model table? Well, right now we don't. So we're going to create a model table. That model table will have a model ID. We'll have a language, R or Python. We'll have a model type, linear, XGBoost, maybe something else. We'll have the model itself, and we'll have whether or not it's native scored. Now, if you're a database administrator, you're watching this, probably got a little bit of consternation saying, wait a minute, are you telling me you're going to store the var binary max data for that model in my database? This sounds like a bad idea. And to the database administrator, I would say generally completely agree. I'm the type of person who says if you store images in a database, the images really shouldn't be in the database. They should be somewhere else with a reference to where those images are. Databases are not very good at storing unstructured binary data. It's a very expensive way of categorizing files. But there are a couple of reasons why we might want to store the model here. Reason number one is I may not get access to the file system. By default in SQL Server 2019, our security setup means that an ML services SP execute external script call will not be able to read any directory other than a temp directory that is created for that call and will only be used for that call. So you can't access files on disk without explicit permissions explicitly being granted. It's on purpose. It's to prevent somebody who got access to your server from using R or Python to then exploit other servers. Even if you can, if you want to use native scoring, the model has to be here in the database. Even if you don't want to use native scoring, it is a lot easier to pull the model from here. And frankly, you're not going to have many models. And the models that you do have will generally be in the bytes or maybe kilobytes range. You know, if you're talking about storing a large model, hundreds of megabytes, gigabytes, yeah, I would agree. I wouldn't put it here. Actually, what we did was for a large aggregate neural network model, like I mentioned, we actually packaged that up. It's in the R library. So that way it's brought into memory. It is stored on disk, but it's stored on disk in a place that the R service is allowed to access. But there's some rigmarole. There's some steps to getting that model out. So I would say don't be too concerned about seeing models in a database like this, especially if we're talking one-off or onesie-twosie types of models. Okay, let's train a model. So I like to create a stored procedure that is specifically for the R or Python code. And then I like to create a wrapper stored procedure that calls the internal procedure. And I'll show you why. Here is the ML procedure. I'm going to get a language. I'm going to get a model type. I'm going to get a trained model as the output. So we will declare SQL and a rote command. SQL command is going to be the SQL to get our data. In this case, our data is expense data prior to January 1st of 2017, which is when we know that the fraud began. I'm going to take amount, and by the way, I have to cast it as a float. The reason is Python does not support T-SQL decimal. So my amount is actually as a decimal because I like, you know, having numbers be correct. But Python requires that it be float. So in this case, it's not going to make a big difference. But in case you're dealing with, you know, proper monetary predictions, realize that we're now switching to floating point. Okay, if the language passed in is R, I need to set up some R code. Basically, that R code will load the expense reports R package and will call within expense reports R the train model function, passing in my expense data and the model type. So for model type, I just put this little flag, 0 in curly braces, and then I replace 0 with curly braces with my model type that is defined as an input parameter. So that's if the language is R. If the language is Python, note that I'm now flush left because Python is white space sensitive. So I don't want to have any spaces. With R, I could tab it in. I can make it look okay. With Python, nope, that will cause problems. So here's Python. We're going to import the pickle library. And from scikit-learn ensemble, we'll load random forest regressor. In R, we're going to do linear regression and XGBoost. In Python, we're going to do random forest. So reg is a random forest regressor, and we will fit our random forest regressor, give an expense category ID and year. We would like to explain the expense data amount. So we do this. We're going to fit our result. We're going to dump that as binary, as a pickle file. So actually as binary, not as a file. We've got this trained model that is the serialized model that we've created. Regardless of the language we chose, here's our script. sp execute external script, send in the language, send in the command. Our input data will be that SQL statement. Our input data name will be expense data. You notice that I called expense data up here. I call expense data over here. That's where we got the name. So it comes from here. Output parameter of trained model. So I do want to call this out. My parameter is trained model with no underscore, but you can see I use trained underscore model in these cases. The reason I do that is strictly for andragogical purposes, strictly for explaining that you don't need to have those variables named exactly the same. Probably should. You can, you should. But I just wanted to point out that, yes, you could, in fact, have a different name here. All right, let us create this. So I've created the procedure, but I can't run it yet. The reason I can't run it yet is I'm supposed to call this expense reports R, but it isn't there yet. So let's come back to SQL MLUtils. By the way, let's check this. Okay, packages were installed, so we're good. I am going to run install packages and install this expense reports R binary. So here's my zip file. It's going to install on the server, on the SQL server in the database. May take a moment, so we'll let that install. This may take some time. While that's happening, let's come down here. This is just a quick test. Declare trained model, execute Python random forest regression. So I don't even need the R package right now. So I can actually run this right now. So let's do that. I run this thing, and we're going to see another wait. External script network IO. So external script network IO is another version. It's another wait stat, and that is around essentially saying, well, we have sent our data. We are sending our data out to Python or to R to run. And now we're waiting on results to come back. You can see this wait. It may take quite some time for things to finish up. That is by far the most common wait for me with machine learning services. It's essentially something is running. When it's done, we'll stop waiting for it. So there's no problem with that wait inherently. And what we get back is this binary mess. A lot there. I can't interpret that. It's all binary. But it does show that we got back the trained model. So now here is my wrapper procedure. Wrapper procedure takes a language and a model type. And what it does is declares trained model and calls the trained model ML. Then it inserts into the model table the results of calling that procedure. In other words, this is the procedure that my application would call. This is the procedure that we normally call. But if I need to understand why the R or Python code is failing, I don't want to call this thing because, you know, it does stuff. It modifies data. Instead, by having a separate procedure, I can troubleshoot that procedure without doing anything downstream. So that's why I like to have them separated. There's not going to be a performance difference. You know, we're talking about calling a procedure inside a procedure as opposed to just pasting the code in. There's not really going to be a performance change. But there will be a change in your ability to troubleshoot without having to comment out possibly hundreds of lines of code in a procedure. So let's create this thing. Just in case we had data, we no longer have data. And I would like to run linear training, XGBoost training, random forest regression training. Let's make sure successfully installed package. So SQL install.packages worked for us. This was a package that I built. I didn't pull it from CRAN. Notice that the repos is null, which means that's a local file. So I got it from expense reports R 010.zip. I've built that before. I've built it in the past. So let's run this. This will take a moment to finish up. All three of these models are pretty fast. There's a reason I chose these rather than something a little bit more complex. They're good models. They actually do the job reasonably well. XGBoost, for example, is one of the models that quite often wins Kaggle competitions. It can do a great job at scoring. Random forest regression often ends up being really good. Even linear regression, if you have a linear problem, linear regression is perfectly fine. So we have our outputs. I'm not really that concerned about those references there. Instead, I want to look at dbo.model. And I have 3 models. Drag this down just a little bit. Models 1, 2, and 3. 2 of them in Python. Linear, XGBoost, random forest regression. I have the model stored, and here's the model size. So linear model is 200K. The XGBoost is 30K. The random forest regression is 26K. Not exactly blowing out the database here. Also, because in order to have ML services, you need to have a recent version of SQL Server, we could actually use the gzip functionality in SQL Server when storing by saying something like compress. So if I compressed the model, you can see that it gets a lot smaller. Now I would have to uncompress it afterward in order for it to be available again for R and Python to use, but these types of models are very compressible. I've seen things where I've got 20 or 30x compression ratios. Even this one, this is about a 10x compression. This is about 6x. This is 3x. So you go from what, 260K to 40, 50K? Not bad, not bad. So we've trained a model. Now I want to generate some predictions. It's going to be a whole new file right here. First, let's go back to R. Because I showed you one file. I didn't show you this file. We open up this one, and generate predictions is another function. Takes an input data set, a model type, and a serialized model. So once again, we check, make sure that it's one of our models. By the way, just in case you were curious, let me show you an example where we call this, I'm actually going to do this one. Let's say we said R, random forest regression. I run this, and what it should do is spit back an error that says, hey, this isn't one of the output types that you said we could do. Error, model type must be either linear or XGBoost. You passed in, well, apparently my error message was bad. But had I done a better job of testing this, I would have said, you need to pass in a model that's linear or XGBoost. So give you a quick idea of what's going on. Okay, back to the regular show. Generate predictions. We pass in a model, we check it out, and we need to generate some predictions for that model, either linear regression or gradient descent boost. Or there's an error message that we know won't work. Okie doke. Generate linear predictions. Input data set and serialized model. Well, I have a serialized model, so I need to deserialize it using the unserialize function. And that gives me back a deserialized model that I could then call rxPredict on. So I've got my model, I've got my data that I would like to score. I've got, in this case, it's going to be year and expense category. And based off of that, we're going to predict amounts. Here is XGBoost predictions. We're going to load XGBoost in data table. I need to deserialize the model again. I need to turn my expense year and expense categories in my scoring data set into a matrix, and I run the predict function on XGBoost. Once I'm done with that, I column bind input data set with my predictions. In both cases, prediction is just the dollar amount that was predicted. It's the label. So I want to slap that back in with the input data so that we can compare what the predicted result was versus what the actual result was. So my ML function, language and model type, my code will look at data after January 1 of 2017, when we know that there started to be some corruption. We are going to query the model table and grab the model that represents our language and data type and is not native scored. I haven't gotten a native scoring yet. So if the languages are, expense reports are generate predictions. And if the command is Python, we're going to load pickle and pandas. We're going to take our trained model and deserialize it in pickle. And then we're going to create a data frame of the prediction. And then we're going to combine the expense data input with the prediction output as columns. So the column will be smushed together into output data set. I have this thing output data set. That's going to be important to remember. I also have expense data. Expense data is my input. We've talked about that before. So here's my call, sp execute external script. Input data is a SQL command. It is on expense data. We send in a trained binary, but don't get a trained binary back, because we don't train a new model, we use the model. So my output is a result set, and it is a result set with a single result set that includes all of my inputs plus the amount predicted. Yeah, go ahead. Oh, am I? Okay, I have pretty crappy internet these days, it seems. So hopefully, let me repeat this a little bit so that everybody's clear. Basically, my input data set was based off of the SQL command that got all data after 2017. The output data set that is called output data set, this is a default name. If I don't specify the output data set, SQL Server will look for this. And I define what output data set looks like using the with result sets command that came out in SQL Server 2012. So this is the shape of my output result set. It is all of my input data plus the prediction. We're gonna build this. Then my generate predictions function loads data into a temp table. And then we're going to query that data. So let me just run this. There we go. Quick discussion about the query itself. Predictions. We're going to take amount and amount predicted, and I'm going to bring them back to decimal because I really don't like the fact that it's float. So we'll cast them back as decimal. Then I'm going to say, all right, how many expense reports? What was the sum of dollars spent? What was the sum of predicted dollars spent? What was the difference between them? So this is MAE, mean absolute error. And basically you can read this as the sum of amount predicted minus the sum of amounts. We'll take the absolute value of that and divide that by the number of records. So if I predicted in total $1,000 and we really spent $1,200, and that was over 100 expense reports. So 1,000 minus 1,200, negative 200, absolute value of that, positive 200, divided by 100 is 2. So we are off by $2 on average per expense report. That's MAE. MAPE is the percent difference, the percent error. So here we have $1,200 minus $1,000, so $200, divided by $1,200. So that would be 1 over 6. So it would be roughly 16.7% error. So mean absolute percentage error. These are two different ways of evaluating the efficacy of a model. They're not the only two ways. They're not necessarily the two best ways, but they are two easy to calculate ways in SQL Server. So we're going to do this for XGBoost, linear regression, and random forest regression. We're going to run each one of them in turn. What was that word again? I don't remember which word I said. I say a lot of words. Some of them even make sense. So, Ryan, if you can remember the word, I can at least say the word as though I meant to say it that way. While this is going, this seems like a good time for me to run who is active again. And we can see we are waiting on network IO. Basically, script is running. R and or Python is doing its thing. Just got to wait for it. We've waited for it. Okay, so we got messages. I don't care about the messages. What I care about is the results. I have 3 separate result sets, and I'm going to pop out one level. Hopefully that's still visible. But here's what we have. This is, let me see. Actually, you know what? I'm going to do one at a time. Probably be easier to read that way. So here's XGBoost. We're going to run it. It'll take several seconds to run. And what we're going to come up with is, there we go. Number of expense reports, total and prediction. So we can see that we're off here 14 to 15%. Here we're off by, so about 15% off by $14. For Bondon and inexpensive cities, we were off by $1.95. So you can see that we're off by $2, $8, $5, $10, $18. I mean, we're off by a pretty substantial amount. In this case, XGBoost is not a great choice, given the parameters that I used. I'm not blaming the algorithm. I'm probably blaming me. So if I were to say, I'm going to use this to determine how much we lost as a result of it. I don't know. The opposing team can easily say, well, wait a minute. You know, you're admitting that you're off by 10 to 15% on everybody, at least 10 to 15% on everybody, including the people who committed fraud, but also the people who didn't. I know for a fact that Jack Aubrey did not commit fraud, and yet you're still 10 to 12% off on his predictions. Not good enough. So we're going to try linear regression. Good old linear regression, one of my favorite forms of regression. Here we go. Here we're off by 1%, negative 2 to 3%. So much closer to accurate, except for somebody like Ebenezer Graham. So Ebenezer, we're off by 39% on inexpensive cities. But notice on expensive cities, we're spot on. For moderate cities, we're off by 7%, 8%. And keep going down. This is pretty accurate. Oh, here's another person who, by the way, was committing fraud. So you can see that for the people who committed fraud, we can catch the error here. We can say, oh, these are way off from the prediction. The cases where we know that people were not committing fraud, we're within a couple percentage points. So we're pretty confident there. But interestingly, an area that I didn't even tell you so much about was moderately expensive cities. In this case, with moderately expensive cities, the mean, if I go back to the slide, that mean was over $40, and it didn't change very much. It might have changed just a tiny bit here, but that's hard for a person to see. So we learned as a result of this model that there was an error here, error term of like 8%. And here's another person who was a fraudster, 10%. So what we can do is we can calculate the differences between totals and predictions. Using that calculation, get the estimation of what it should have been for the people who we knew were, and they really didn't commit fraud on expensive cities. Like Sophia, for expensive cities, again, we're right on. They only committed fraud here and here because you went to New York City, you were spending more than $40 already, so you got that receipt. Last bit, deploying custom code. So I already walked you through all of that. So wrapping things up for tonight. Machine learning services gives you the ability to operationalize both R and Python code pretty effectively. It can serve as a good way of bringing machine learning models to production. There are cases where ML services is not a good choice. There are cases where it is a fantastic choice. If you'd like to learn more, go to csmore.info/on/services-dev. And let me copy that link into chat here. If you have any questions, please feel free to reach out to me. Email address, Twitter handle are on there. Also, if you want to get the ML services in production talk, which is a bit different from this one, it's csmore.info/on/ML services. And with that, if there are any questions from anybody, I'm happy to take them right now or, whenever. Yeah, I can stop sharing screen here. And then we'll go back to me as me. All right, Ryan. So I know you and your team have been using ML services for a while now. In production, are you using XDF data frames often, or can you get away with using regular data frames most of the time? So we almost never use extended data frames. The difference between regular data frames and extended data frames, real short, is extended data frames give you some nice functionality like paging to disk. I have a huge amount of data and I can't fit it all into memory, and my model crashes because, R crashes because it runs out of memory. I can use an extended data frame and page in and out of memory, so write to disk and read from disk, and work on this in smaller sets. We have used this a few times. Typically, though, our models tend to be focused on a fairly small amount of data, but we usually have a lot more models. In cases where I have, for example, a very large, like the aggregate neural network model, that was trained on a separate machine that was built with GPUs. It had all of the data sent over to it and was a one-off training job. for a lot of our regularly retrained models, we don't have to use XDFs for that reason. Partition-based model feature. If so, what are your thoughts about them? We're not using partitioning. This was introduced in SQL Server 2017, if I remember correctly. It may be 2019, but I want to say 17. And essentially, it allows for parallelization. So I can parallelize certain models if I'm thinking about what Brian is asking. So I can take our code, and historically, our code is single-threaded. So I have the thread that is running all of the stuff, which means if you have 20 cores, well, historically, R only uses one core. You can parallelize operations, and within R, there are libraries to help you with this. There are parallels libraries. ML services has, as most of the RX functions, they are natively parallelizable. So they are also natively multi-core and allows you to take better advantage of CPU resources on a machine. So I can spike a 16 core or 32 core server at 100% CPU because I've got multi-core functions. Now, as far as parallelizing code, specifically what'll happen is if you have, say, a loop and you have a bunch of different elements in the loop, or you have a data frame and you're generating predictions for each element, each observation in the data frame, ML services can split that up and make those calls in parallel. That may be faster than what you've got natively. It can only do that if there are no references between elements. So each element in the data frame can operate fully independently. There are no links to other elements in the data frame. If that's possible, you can turn on parallelization and get some performance improvement. We have not used that because the models that we're using don't really support this type of parallelism. So we tend to use a lot of TensorFlow and Keras models, which means that we're not going to get any advantage from that parallelization within ML services. I wait for another question and watch myself on time delay. Interesting seeing like, oh, yeah, I did just say that.
All right, folks, take a minute here, bring in other questions, take advantage of this great opportunity. I know that you all have seen and be exposed to a lot today. And as Kevin mentioned, there are some resources he has put out there. I will capture and add to the comment section as well for you to follow up. You know, great, awesome presentation, very enlightening, covering from installation to external scripts, building projects, deploying custom code. You had pretty much 360 along with demos on the use. Kevin also outlined the pitfalls, ways around those pitfalls, and going way and above and beyond the different ways you can do and implement SQL Server machine learning services using R and Python here. So if you have questions, you still have a chance over here. Don't delay. And remember, before you leave, like and comment. And let's see if we have any more questions here. All right, and thank you very much, Ryan, for the questions, the input. Really appreciate it there. So can you remind us again here, Kevin, where can we get these resources? And we will also add to the comments, as I mentioned.
Yeah, sure. So that's all at csmore.info/on/mlservicesdev. There's a link right here in chat. Looks like you'll have to copy it and paste it. It's not a high. But that'll give you the sources for this talk. If you did want to learn more about native scoring, I know that I didn't give it as much, didn't give it much in this talk, but I do talk about it more in this other talk on ML services. So I've got scripts on how native scoring works, and you can see how that's built up.
Outstanding. And maybe you can, we'll see if you may be interested and have an opportunity to come back and take and present that other presentation here and getting more in depth about the topic itself.
Well, that is a possibility.
All right. All right. Anything else you want to add there, Kevin?
No. Hopefully that was enough for people for tonight. Hopefully filled up brains. If you do have questions, you want some sort of follow-up, email address, Twitter handle, right there for you.
No, you may. All right. Yes, and I believe it's also on the. We have that information down the comment section. If you are coming in later on and you are unable to view that, it's on. I'll make sure it's down here in the description, folks, so you can always follow up. Yeah, and engage and great. All right. Everybody, thank you very much for attending another great presentation here, and our first time guest here, Kevin Feasel, developing a solution with SQL Server machine learning services using Python and R. So great quality. We all get to learn a lot about it, including veterans. I had an opportunity to ask questions. If you want to follow up additional questions, I will update the description section with additional resources. And that's all for tonight. Anything else? Any last words out there, Kevin?
No. Thank you, everybody, for watching.
Thank you, everybody. Stay tuned. In 2 weeks, we'll be back here. That will be on October 7th for another Microsoft Data and AI South Florida presentation, and we will also have another person from the US presenting, and on Tuesday, September 29 is the South Florida Power BI user group. We will have someone from Austria presenting as well, so we'll be putting out there on the channel will be a listing for that presentation and ways to how to and where to register for it. So thank you very much. Thank you very much, Kevin. Really appreciate that. And, have a good night, everybody. Bye bye.